So I'm going to go ahead and start. My name is Marty McGuire. I'm here to tell you about the Blinky tape, a story of art and open source and Shenzhen and Kickstarter. I'm going to lead off with two apologies. One, as you can tell, all of those things added together is actually like 4 talks, so I've crammed them all down as sort of as best as I can. The second is that this is a story in progress. I would love to tell you that we have like super hardcore processes in place for everything that we're doing, but it's a team of 3 guys and we're up to our eyeballs in it. So if you feel confused, welcome. So what about me? So I'm a software guy. I've got a little over 10 years of software development, so I'm a pretty young guy, I guess, when it comes to like building stuff and getting things done. I worked at academic research labs at Carnegie Mellon building like crazy DARPA secretary replacement prototypes. And I worked at MakerBot for the last 2 years. Recently left them in March, just before they got acquired. They had nothing to do with each other. I'm also a little bit of a hardware hacker. Hardware hacking is kind of less of a thing. Anybody who here knows what a hackerspace is? Or who has no idea? Okay, so more know than don't know. That was awesome. This story is mostly not about me, but it is partially about hackerspaces. So a hackerspace is kind of, in this case, we're talking about a hackerspace named NYC Resistor. It's kind of an art and a code collector, like an art and tech collective. So people, especially in New York City, don't have a lot of space to have workshops, so a bunch of folks get together, they rent a space, and they pay for really cool equipment like lasers. In this case, this story starts with a group buy of a few $1,000s worth of LEDs from China. You can see them here on these spools. Basically, these are long strips of LEDs that you can power them on one end and run a single data line to them and pump out everything over like 8 meters of LEDs. It's pretty impressive. The goal was to build an LED installation for Burning Man. And this is it. This is called DomeStar. So each of these strips of LEDs is 5 meters long, and they're all controlled by a board that has 8 connectors. So each board runs out to 8 of these strips. Then those boards connect over USB to a laptop that's basically running all kinds of stuff. So there's just pretty light shows, there's music reactive stuff. There was even a demo using a Nintendo Wii remote, so they could do like a fake sort of spotlight thing, and there was a button on there to engage seizure mode, which was actually not that popular. Yeah, so DomeStar and actually a lot of hackerspaces are really into this idea. And apologies to Chris in deference to patent protections. But what I'm going to talk about today is open source hardware. Who here has heard of open source hardware? Okay, a few. How about open source software? Okay, more. So open source hardware is kind of like the hardware version of open source software. The difference is that when you have hardware, you're not just releasing the code that's going to run on a device or the code that's going to run on the computer. You're also releasing the files that describe how the hardware is made. So in the case of circuit boards, that's going to be the traces where your circuits are going to go, the subscreening that's on top, the physical layouts of the board. For enclosures, that's going to be like a 3D file that someone could 3D print or cut on a laser cutter or even take to a professional manufacturer. One of the things that we really believe about open source hardware is that it lets you move super fast because you're leveraging other people's existing designs. It also means that you automatically have community built in because you're dealing with communities that already understand the designs that you're building on top of. The cons are, in our case, a lot smaller, which is maybe you'll get cloned. People worry about that a lot, and it happens. But if somebody's going to clone your product, the fact that you didn't release those files is only going to buy you a couple of days of an engineer's time for the most part, depending on how complex your stuff is. What we're talking about is pretty simple on that scale. So who here doesn't know what an Arduino is? A couple. Okay, cool. The rest of you, I apologize for explaining this. But the Arduino is a cheap, about $30 hardware prototyping board. It's basically a tiny computer that you program using your computer over USB, and it interfaces with things in the real world. So it can light up lights, it can read button presses, it can talk to RFID tags. It's sort of an interface for physical computing. And it was designed for students and designers who don't have a programming or an electrical engineering background. And it comes with a free programming environment. So once you have the board, you can download stuff and start going right away. It also has an enormous online community. So pretty much anything that you would want to do with an Arduino, somebody has already done it. And that's everything from like building a 3D printer, yes, there are 3D printers that are powered by Arduino, to whole house automation systems. And this is all out there. Processing is similar to Arduino in that it's a software environment designed for students and designers, but it's more for the PC side of things. So it lets you very quickly bang together like pretty graphics or test out mathematical algorithms or sound, or in our case, we're using it to make user interfaces. And I'll talk more about that in a bit. But another two big benefits there, it also has an enormous community so people know how to work with it. And a lot of folks use it in cooperation with Arduino. So if you've got an Arduino project, it's really easy to talk to it from your PC using processing. Those two things together make it really easy to make hardware that kind of like smarter hacker people can understand, but also using processing to make apps that anyone can download and run to talk to that hardware without having to know what they're doing. So given all of that, LEDs are still hard. With the Domestar development, most of that time was actually spent on solving problems like power distribution, dealing with networking architecture, like how are we going to push all of these bits, all of these strips, and do it fast enough that people aren't just sitting there waiting for the LEDs to refresh. And then figuring out how to enclose it so we could actually run this in the desert. That actually did not leave much time to make awesome LED art. So a lot of the development of the board, of the system, was just spent in getting it to work. And that only left a few days basically to bang out interesting demos. So that kind of makes it difficult for people to duplicate. We've seen a few sort of more tech-savvy people take the files that are out there and make new designs or make cool things out of them. But mostly what we got was requests to make an out-of-the-box version, something that people could just buy and plug in and start making pretty things. So after that project, along came Hackcelerator. Hackcelerator is the China hardware accelerator, China hardware plus accelerator tools Hackcelerator. It's a 4-month program in Shenzhen, China. When you apply and are accepted, you will get $25,000 of seed money. You'll have space in the office / prototyping lab that is Hackcelerator. There are actually a few really cool tools there, like a 3D printer, a CNC mill, and a pick-and-place machine for people doing electronics. And all of this is located in what's called Huashangbei, which is the amazing electronics district in Shenzhen, China. If you've heard of the amazing electronics district in China, that's probably the one they're talking about. As part of being there, you're going to get a bunch of mentors, so people to help you guide your business, but also to introduce you to the community of suppliers and manufacturers around there, as well as actual tours of factories where you can meet the people who are going to be making your stuff. You also get a native speaking and writing administrative assistant with the program, which is incredible and is probably the #1 benefit, I would say, if you're going to be doing manufacturing in China. So like I said, it's the heart of the electronics district. These are some photos from a couple of the booths that are just in actually one of these. So up in the upper left, we have, I think these are all power regulators, and there's tape describing what each one is rated. There are a bunch of connectors of all different colors and types over here. This guy is just selling loose LEDs as well as like some pre-assembled displays. And then this picture, I guess you can't see it too well from here, but that's like 5 of the 8 stories of this building were like, it's nothing but booths like this. And that's things where, it's sometimes components, it's sometimes prototyping hardware, but you can also buy, your knockoff iPads and laptops if you want. And this is just one of dozens of buildings that have these kinds of things there. So if you like to make things and you know what you're looking for, you will never find a better place to go buy the stuff to make it. So what did we do with this? Well, we wanted to make LEDs easier. And the first round of this was a system we called the Blinky board. The Blinky board, you can see one of the boards here. Essentially, it's a tiny circuit board that's Arduino compatible, which means it uses the same chip that one of the Arduinos uses. So you can plug it into your computer and program it using that same Arduino programming environment. They're fairly cheap to manufacture. They're equivalent to some of the smaller Arduinos. You basically, if you're a little bit savvy, you source your own LED strip, solder this down, and go to town. You make whatever you want. Some of the cons with this design are basically like it's actually not cheap enough. You can already buy these LEDs and then either from China or there are some local sellers in the U.S. And then buy your own controller. And for the price we could sell the Blinky board, that's actually not a super great value because you have to source those separately. You have to solder. You have to bring some expertise to what you're going to build. That still means you're going to solve your own power problems and you're going to solve your own enclosure. And we would solve the programming problems, but that's not quite good enough. So to make LEDs awesome, we created the Blinky tape. So it's essentially the Blinky board plus a 1 meter long strip of 60 RGB LEDs plus silicone tubing to make it a little bit weatherproof. It still has a USB plug on the end, so it's not, don't go dipping it in water. The nice thing and the real target here was that it's usable out of the box. So by making this available and making software that can run in the processing environment, we were able to give people something that they can buy, open, and immediately begin making patterns on or making interactive demos with. And that's all done over a single USB connection, so there's no separate power source. The cons, there's a fixed number of LEDs. One of the first things people asked was, can I make it longer? Can I chain these strips? And the answer is no, there's no way you can draw all that power over USB. We're essentially at the limits of what even a really nice USB system like a Mac Pro can put out. So, future revisions. All right, this is the part where I do Kickstarter boot camp. Does everyone here know what Kickstarter is? Or rather, does anyone not know what Kickstarter is? A couple don't. Okay, so Kickstarter, crowdfunding. Basically, you tell people about your project, they give you money in exchange for rewards. Failure is very cheap because all you had to do was make a nice Kickstarter page and, in the case of hardware, show off a nice working prototype. Whereas success means you already have a passionate community of backers and you've demonstrated demand for your product. Limitations are currently if you're selling hardware, you can only give out one, like in our case, Blinky tape per backer. So we can't actually do distribution deals through Kickstarter. Kickstarter also takes a cut, and then once you succeed, you're on the hook. You have to make this stuff, and if it runs over budget, that's on you. So plan accordingly. What you need to bring is a working prototype, really good costing estimates. You should have already talked to the factories and gotten a sense for what it's going to cost you for various quantities. You're also going to need to figure out your reward levels. People want more than just your product, so they want accessories. Sometimes they want T-shirts. People are backing your idea as much as they're backing your product and making that happen. You also want to bring tons of applications, and each use of your product is another group of people who would not buy it if that didn't exist. That was why I'm an applications engineer. And of course, you want a story and you want an awesome video. So this is where we find out if this works. Maybe it doesn't. Go to the volume here.
Controlled by our custom light processor.
Sorry guys, let's try that again.
Hi, we're Blinky. We make LEDs awesome. We've had a lot of fun making LED projects in the past. However, we've been frustrated by how difficult they can be to program, power, and close. The Blinky tape is a 1 meter long strip consisting of 60 independent RGB LEDs controlled by our custom light processor. We created the Blinky tape in order to make LED projects painless and powerful.
Open the pop bay doors now.
I'm sorry, Dave. I'm afraid I can't do that.
So good.
But what we're most excited about is what you're going to make. So check the backer rewards on the right to find out how to get your own Blinky tape, and check out the details below. Thanks for watching.
Thanks for backing.
We love you guys.
Those are the other two guys. Those guys actually do most of the work. They're the double E's and the smart ones, and I just get to make the cool apps and processing. I'm almost out of time, so I'll go through this really fast. Our campaign strategy was to look like an active project, which we are, but the idea is like release new content every week. So basically it's like there needs to be a new demo or application every week while the Kickstarter is going on. We actually did very minimal marketing. We just did like social networking, friends and friends of friends, and then most of our sales actually came through Kickstarter internal. So making your project something that the Kickstarter people like is really important, because there is a huge crew of folks that just troll Kickstarter trying to give money to things that they like. And if you can get featured, you will be one of those things. It's also important to respond to questions and feedback very quickly. Of course, this worked for us and this product. Your mileage will vary. Did it work? The answer is yes. So we aimed very, very low. We wanted to make at no less than 250 units, which we costed out to be about $15,000. Like if our cost estimates are right, if our shipping estimates are right, and given like at least one big screw up. What we actually raised was about 530% of that. So we're going to be moving over 1,000 units. That's really great. That means we can actually talk to some of the larger manufacturers and get some of the better discounts. It also means we get better turnaround times and responsiveness from those guys. What's next? So that's kind of the end of the story. Just kidding. That is the first act of the story. Now we actually have to do this. So Matt, one of the founders, is over in China now. He just arrived last Wednesday, I want to say, to actually get manufacturing moving again. So we'll be actually doing that. We'll be talking to distributors like the Maker Shed, for example, to actually get these into web stores. So not just our Kickstarter backers will be getting them, but we want to make them available for people to buy as well. And of course, we're like keeping our backers in the loop and hopefully delivering on time. Thanks. Sorry I ate up a lot of time. If you guys have, I know there's a lot in there, so if you have any questions that we didn't cover here, like feel free to grab me. You can see me on Twitter or come see me and grab a card. I'm happy to talk about China, Kickstarter, or prototyping with processing, any of that stuff. I can make time for like 5 questions.
Just a couple questions.
Yeah.
Who's your customer and what problem are you solving for them?
Who is my customer? My customer is anyone who doesn't have enough light in their life. But in seriousness, we see a lot of, so we came out of the hacker community and like we're a group of people that did light projects. And when you do that, you meet a lot of people who do light projects. So we're talking about people who build things for Maker Faire, do things for stage art, fashion designers that are starting to work LEDs into things. A lot of people who do like interiors for bars and clubs. These are all things that you can kind of like quickly begin playing with using the Blinky tape, and then if you want to scale up, you would use something else. Yeah.
What's your production stage margin on something like that?
How do you mean?
Are you making 500% on each item once you're producing them in mass?
No, and we're sort of taking shortcuts because we're a very small team, and what we're doing is working with companies to actually handle things like fulfillment. So like we're not running our own fulfillment center, we're not planning on running our own web store. That comes with increased costs. But essentially, we were selling these through Kickstarter for about $60 a unit, and this isn't 100% figured out, but we're thinking that it's going to cost us on average about $35 to actually get one of these made and shipped. So, not amazing margins, but our goal was really more to learn than to strike a deal. Anybody else? All right, well, thanks very much.
That was cool.
Thanks for putting
Beat that.
Yeah.
Oh, is that like the reactor?
Yeah, it's just something like that.
So you're not going to use slides, right?
Sorry?
You're not going to use slides. Right?
Yeah, unfortunately not. So I love what he's doing because he's leaning into a whole bunch of completely new things that just a few years ago didn't even exist or they were in there. So it's cool. And I've actually worked with Chris. I had the good fortune of working with him on a project in Black & Decker, which was a lot of fun. If you ever need anybody who can figure out what the consumer is trying to tell you and they can't.